Hi, and welcome back to Educator. Today we're going to talk about recrystallization, or some people like to just call it crystallization, which is a method used to purify solids. So let's assume that we have a crude solid. Maybe we just ran a reaction that has a solid product and we've isolated that product, but it has some impurities trapped inside it. So the goal of a recrystallization is to first dissolve that solid in a hot solvent, and that's going to give us a hot solution. So our crude solid and whatever impurities are there are going to dissolve, and now we have a solution. We take that hot solution and we cool it, and that's going to cause a crystallization, because if we used a minimum amount of solvent here, then our hot solution is going to be have a lot of our solid dissolved in it, and as we cool it, the solubility decreases, and our solution is going to be super saturated. It's going to be holding too much solute for the amount of solvent that we have. So it's going to cause the solute to crystallize out. Now we have a solvent that's mixed with solid, that's mixed with our crystals, so we're going to filter. We're going to get our crystals out, and now this should be a pure solid. And what we're filtering off is the solvent that's called the supernatant liquid, or the mother liquor, and that solvent is hopefully going to contain the dissolved impurities. So the assumption here is that the amount of impurities you have in your crude solid is relatively small, and so as we cool the solution, it's not going to be super saturated in the impurities. There's still going to be plenty of solvent to keep the impurities dissolved, and so when we filter off the solvent, the solution from our crystals, our impurities are going to get washed away with that. But we're also going to have some dissolved solids. So we have our desired product has some high solubility in hot solvent, but when we cool it, it's not going to have, it's unlikely to have zero solubility in the cold solvent. It's just going to have a lower solubility. So when the crystallization is done, some of our product is still going to remain dissolved in the solution, and so that's important to recognize, is that every crystallization process it results in the loss of some product. But the goal is that even though we have less product now, it's going to be more pure. So what is the theory of crystallization that works here? Kind of what I just said. We have a small amount of impurities. We're going to try and do our cooling very slowly, and that ensures that the crystals are going to grow slowly and have a nice chance to form. That's going to ensure pure crystals. And our impurities should remain dissolved along with some of our desired product that remains dissolved. What we don't want is precipitation. So if we cool it too quickly and have our solid product just precipitate out rather than crystallize out, then when that precipitation can trap impurities along with it. So some of your impurities, even though they might want to stay dissolved, might come crashing out with the solid. So we want to have a slow opportunity for it to cool as long as possible. And they don't necessarily end up being large crystals. Some crystals grow to be very large. Other crystals always end up as very small, fine needles. But the idea is that we want to have well-formed crystals.